Now let's move on to the price prediction part. This script is a comprehensive crop price forecasting tool using machine learning specifically for vegetables in Sri Lanka. It begins by loading historical price data from uh, Google Drive. That the data set is stored in the Google Drive, covering years from 2000 to 2024. The process is repeated for each crop such as tomatoes, cabbage, and chili. For each crop, the data is cleaned and aggregated by month to make it more consistent for forecasting. Then new features are created including lagged prices from previous month, rolling averages, seasonal indicators like month and year. A machine learning model, specifically a random forest regressor, is training to understand the trends and patterns historical prices. Once trained, the model is used to make future predictions up until 2028. The model outputs both graphs showing actual past prices and predicted future prices as well as evolution matrices like RMSE and R squared score to show how well the model performs on the test data. In summary, this tool helps visualize and forecast vegetable prices over time, making it useful for farmers, traders, and agricultural planners who want to make data-driven decisions. So, the next part, the demand forecasting. This script builds a time series forecasting tool that predicts the monthly sales volume of various vegetables in Sri Lanka using Max model, a powerful satisfactional forecasting method. It starts by loading comprehensive vegetable price and sales dataset from Google Drive. The data includes information like crop names, dates, and how many kilograms were sold. Next, it filters the data to focus on set of key crops like tomatoes, chili, and cabbage, and groups the records by crop and month, summing up the total sales in kilograms for each period. The core of the script is forecasting the function trains Sarimax model on historical monthly sales data for each crop. This model captures both trends and seasonality in these in the sales patterns, making it well suited for agriculture data and across the month and seasons. For each crops, the model is used to predict future monthly sales from 2025 to end of 2027. These predictions are uh, then plotted alongside historical data, given in a clear visual representation of how sales have changed and how they expected to evolve. In short, this tool gives stakeholders like farmers, wholesalers, and policymakers a way to anticipate a future demand and make informed planning decisions based on their data-driven forecast. The Harvest front end is a sleek, interactive, and modern interface designed to empower farmers with data-driven insights. It offers four main features, each mapped to a dedicated tab and empowered by machine learning APIs from the Flask backend. First one is Crop Oracle. This feature predicts how much a harvest farmer can expect based on crop type, province, and district and landscape, and finally the land size. When a user input the details and submits the app, it makes a post request to the predict endpoint, and the backend uses a simple simulation formula for the model to return expected yield in kilograms. In front end, the front end displays the predicted value visually or numerically to the user. So let's try this. Here you can see that harvest is predicted. Now the market pulse uh, shows future price trends and demand for a selected crop. This helps users plan planting and selling decisions around market behavior. This sends a post request to get chart data through the API with crop name and current price and the date. And the backend returns a 6-month price forecasting using machine learning model, that random forecasting model, and a 6-month demand forecasting using Sarimax model. And front end uses to display interactive charts, prices, and demand over the time. And let's try this also. Here you can see the predicted price and the price forecasting and demand forecasting charts are visible now. Let's move to the next feature, the yield shape. This calculate profitability, helping farmers analyze whether a farmer decision is financially viable. When user inputs expected harvest, market price, cost, production, labor cost, and transport, the app sends a post request to the calculate endpoint, and the backend returns revenue, total cost, profit, ROI, and the profit margin. The front end displayed this in the clear financial breakdown to support smarter investment decisions. And let's try it too. As you can see, the profit and the revenue, the total cost and ROI and the profit margin is generated now. And the final feature, the AgroWiki, uh, a knowledge base for farmers offering educational content about different crops. Uh, They are seeing color names, types, and farming type tips. This feature is mostly static or semi-dynamic, and doesn't rely on heavily on the API. However, it could later connect to a API or a database to fetch or update crop-related content. So the API communication flow summaries goes like the all major features relates on Axios fetch based post request to communicate the Flask backend, and these endpoints are predict price and predict demand and get chart data and calculate. Each endpoint sends input values to the backend, receives predictions or analysis results, and renders them using React components and charts. So this is the final look of front end. Here you can see as we included the frequently asked some questions and our features here. So finally, with a powerful blend of machine learning, real-time analytics, and farmer-first design, this system has a potential to transform agriculture in Sri Lanka, ensuring smarter decisions and higher yields and more sustainable future for all. Thank you so much.